Okay. Good evening. So in the last class we discussed. I think this is a problem. This problem, I think, worked example 3 we discussed. So next problem, worked example 4. So here you can see, yes. So write the recurrence relation for Fibonacci numbers and solve it. Okay. So what is the Fibonacci relation actually? Actually, the Fibonacci relation is f of n equal to f of n minus 1 plus f of n minus 2. So this is the Fibonacci relation. Or you can write f of n minus f of n minus 1 minus f of n minus 2 equal to 0. From this you can write the characteristic equation. So because this is order 2, so a square minus a minus 1 is equal to 0. So if you solve this quadratic equation, actually this one you can easily get it. How? Actually you can take f of n equal to a power n is the solution of this recurrence relation. You should take like this. So f of n equal to a power n means, so a power n minus a power n minus 1 minus a power n minus 2 is equal to 0. Okay, so now next throughout divide by a power n minus 2. Okay, you will get a power a square minus a minus 1 equal to 0. So this is the actually the procedure to get a square minus a minus 1. Okay, but there is no need to write this portion. Okay, directly, this is only for understanding purpose. Directly you can write a square minus a minus 1 equal to 0. If you solve this quadratic equation, you'll get two roots. One is 1 plus root 5 by 2, another root is 1 minus root 5 by 2. You can check it. Okay, now the roots are distinct, then the homogeneous solution. Okay, because okay, but the right hand side is 0, the solution. Okay, homogeneous solution is the solution for this recurrence relation. The solution for the recurrence relation is, you can write b1 into 1 plus root 5 by 2 whole power n plus b2 into 1 minus root 5 by 2 whole power n is equal to 0. Now the initial condition f of 0. So usually f of 0 is 0, but this author takes f of 0 is equal to 1. Okay, f of 1 equal to 1. Both of them he is taking 1. F of 0 also you can take what? Instead of 1 you can also take 0 also you can take. But the answer differs, but both answers are correct. Now f of 0 is equal to 1. If I substitute f of 0 is equal to 1 here, okay, so f of 0 that is equal to what? 1, which is equal to so b1 plus b2. Okay, we will get b1 plus b2. So is equal to 1. So this implies b2 is equal to 1 minus b1. Now second one, f of 1 equal to what? 1. So that is equal to f of 1 is 1 means b1 into 1 plus root 5 by 2. b1 into 1 plus root 5 by 2 plus b2 into 1 minus root 5 by 2. N is 1. So now from this 1 is equal to b1 into 1 plus root 5 by 2. b2 is what? 1 minus b1 into 1 minus root 5 by 2. Now 1 is equal to, take b1 commonly. If I take b1, what you will get? 1 by 2 plus root 5 by 2 and then minus 1 by 2 plus root 5 by 2 and then 1 into this quantity. Okay, so plus 1 minus root 5 by 2. Now 1 by 2 minus 1 by 2 gets cancelled. So you will get 1 is equal to b1. Okay, or you can write like this: 1 minus, okay, 1 minus root 5 by 2, which is equal to 1 by 2 minus 1 by 2 gets cancelled, means root 5 by 2, root 5 by 2. So b1 into root 5. So if you take LCM, 2 minus 1, so 1 plus root 5 by 2, 1 plus root 5 by 2, which is equal to b1 into root 5. So now b1 is equal to 1 plus root 5 by 2 into root 5. But we know that b2 is equal to what? 1 minus b1. So b2 is equal to 1 minus b1. b1 is 1 plus root 5 by 2 root 5. So which is equal to, this is actually 2 times root 5. So minus root 5 minus 1 by 2 root 5, or take minus common, 1 minus so take minus common, so 1 minus root 5, 1 minus root 5 by 2 root 5. So this is your b2. Now substitute the values of b1 and b2 here, where in this equation. So b1 into 1 plus root 5 by 2 whole power n. So what is b1? b1 is 1 plus root 5 by 2. So 1 plus root 5 by 2 root 5. Okay, into what? Into 1 plus root 5 by 2 whole power n. 1 plus root 5 by 2 whole power n. And then b2 is minus 1 minus root 5 by 2 root 5. Okay, into 1 minus root 5 by 2 whole power n. 1 minus root 5 by 2 whole power n, which is equal to 0. 0. Yes, 0 equal to 0. Not 0, actually this is f of n. This is the solution. So f of n equal to this. This is your homogeneous solution, but the right hand side is 0, so that's why this is a solution. So this is not equal to 0, this is f of n. So f of n equal to this. Now simplify further. So 1 by 1 plus root 5 by 2 is here also. So take 1 by root 5 commonly. Remaining is what? 1 plus root 5 by 2 whole power n. Here 1, so n plus 1. And then minus 1 by root 5 into 1 minus root 5 by 2, 1 minus root 5 by 2. So 1 minus root 5 by 2 whole power n plus 1. So this is your f of n. That's all, over. Okay, now I think this problem is over. Next idea is solution of non-homogeneous recurrence relation. So actually, in the case of non-homogeneous recurrence relation, the general solution is sum of solution for the corresponding homogeneous relation and particular solution depending upon the right hand side of the given recurrence relation. So homogeneous solution, just now we discussed, the last class also we discussed homogeneous solution. The last problem we discussed is also here, the right hand side is 0. So okay, now for particular solution we will adopt the following procedure. Actually, I'll start from here. Suppose the right hand side is some constant a naught. I'll put a table like this. So depending upon the right hand side, this is right hand side. Suppose the first case, it's a constant. For example, consider a naught. Okay, where a naught is constant. So in this case, how you will choose t of k or s of k? Okay, so in this case, t of k is you'll choose some other constant d naught. Okay, t of k minus 1 is also what? D naught. T of k minus 2 is also d naught. If it is a constant, you'll choose another constant. This is for this right hand side. Okay, next, suppose your right hand side is a linear in k. It is a naught plus a1 into k. So in this case, t of k is also linear. D naught plus d1 into k. T of k minus 1 equal to, instead of t of k minus 1, replace k by k minus 1. So d naught plus d1 into k minus 1. T of k minus 2 is d naught plus d1 into k minus 2. Okay, suppose if you have just a1k, suppose I don't have a naught. Okay, suppose if I have only a1k, that means what? Linear. So in this case also you should take what? D naught plus d1k. So here also d naught plus d1 into k minus 1. So here also d naught plus d1 into k minus 2. Even though if I have only a1k, okay, or I will write r, okay, or suppose if I have a1k, a1 small k, so you should write the same the same thing for a1k also. Suppose you have a naught plus a1k, okay, a1k plus a1k square, quadratic, okay. Third one, RHS. So your RHS is a naught plus a1k plus a2k square. So in this case, what is your T of k? T of k is quadratic again. So I'll use some other constant d naught plus d1k plus d2k square. T of k minus 1. D naught, replace k by k minus 1. D1 into k minus 1 plus d2 into k minus 1 whole square. And one more I'll write d of t of k minus 2. I should write d naught plus d1 into k minus 2 plus d2 into k minus 2 whole square. So this r you can have a1 k plus a2 k square or a2k square. So okay, so or a naught plus a2k square. So anyway, it is a quadratic means you should write the same thing. Now the next one, um, suppose if you have a naught plus a1k, okay, and then plus dot 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 plus am k power m. So okay, so then instead of t of k, you can write d naught here. Okay, maybe I'll write from start from a naught to am. Okay, is most general case. So RHS okay, a naught plus a1k plus a2k square, sorry, a2k square plus dot 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 plus am a2k square. So and then am k power m. So then to take t of k or s of k, okay, depending upon the problem. So you should write here what d naught plus d1k plus d2k square plus dot 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 plus dm k power m. Similarly, for you can write for t of k minus 1, replace k by k minus 1, okay, and then t of k minus 2, replace k by k minus 2, okay. I don't write here, but now you can easily understand this one. Next, suppose your right hand side is some c into a power k, where c is constant, okay. So right hand side is what? C into a power k. C into a power k, where this a is not coincide with not coincide with okay the characteristic root with the characteristic root. Okay, so then what is T of k? Not this a is not coincide with the characteristic root. Okay, T of k is some constant. Instead of c, I'll use a d naught or d1, d naught into a power k. T of k minus 1 is d naught into a power k minus 1. T of k minus 2 is d naught into a power k minus 2. Okay, so that is given here. Next, here the third point, suppose right hand side is again c into a power k, where a is coincide with the characteristic root. Okay, the next case, sixth one, c into a power k, where a is okay, this a is coincide with the characteristic root. Okay, so where a is coincide with the characteristic root. Okay, so in this case T of k, and here a is a simple root. Okay, here a is what? Suppose because simple root na it is only one. Okay, double root means it is occurs two times. Okay, so if a is a simple root, then a coincide with this a coincide with the characteristic root. T of k to write d naught into k small k into a power k. Then T of k minus 1, replace k by k minus 1. D naught into k minus 1 into a power k minus 1. Next, T of k minus 2, you should write d naught k minus 2 into a power k minus 2. The next case, same, everything is same. C into a power k, where a is coincident with the characteristic root, and a is a double root. A is a double root means here d naught k square a power k. Next d naught k minus 1 whole square a power k minus 1. Here what? D naught k minus 2 whole square a power k minus 2. If it is a triple root means what? So k cube, k minus 1 cube, k minus 2 cube. So that is a difference. Maybe I will write for one more. Okay, seventh one. Okay. So seventh one. So seventh one. So c into a power k, Okay, c into a power k, where a is this a is what coincide with the characteristic root, and here a is a double root. A is double root. So if a is a double root, na same idea. Okay, t of k, you should write what d naught k square a power k, and t of k minus 1, replace k by k minus 1, d naught k minus 1 whole square into a power k minus 1. Okay, t of k minus 2, so d naught into k minus 2 whole square into a power k minus 2. So this is the basic idea you should know to solve the problem. Okay, now I'll go to the problem. Okay, look at this problem. T of k minus, this is minus 7 times t of k minus 1 plus 10 times t of k minus 2 is equal to 6 plus 8k, with t of 0 is equal to 1 and t of 1 equal to 2. So homogeneous solution means take the right hand side 0 and write the characteristic equation. It is a square minus 7a plus 10 equal to 0. If from this quadratic equation, we get two roots, 2 and 5. So both of them are distinct. So then the homogeneous solution is what? Some constant. So they will take b1 into 2 power. Here I am using k, that's why 2 power k plus some other constant b2 into 5 power k. So particular solution, I only explained the particular solution. Particular solution here, right hand side is what? 6 plus 8k. So okay, so in this problem, right hand side is what? 6 plus 8k. So the particular solution next. Okay, for particular solution, actually the RHS is what? 6 plus 8k. So that's why I will take t of k by, if it is linear, so that's why I also take linear, d naught plus what? d1k. So instead of d naught d1, you can use some other constant if you want. T of k minus 1 is d naught plus d1 into k minus 1. Next, t of k minus 2 by, okay, there is no need to put arrow, just you can write like this. Okay, t of k comma t of k minus 1 comma t of k minus 2 by, they will write like this. So for understanding purpose, I will put just arrow. So d naught plus d1 into k minus 2. Now substitute everything in the equation. What you'll get? D naught plus d1k plus, sorry, minus 7 times t of k minus 1, d naught plus d1 into k minus 1, close the bracket, plus 10 into t of k minus 2, d naught plus d1 into k minus 2, okay, which is equal to 6 plus 8k. Now simplify and write the left hand side the constant term. Constant term means the terms without containing k, and collect the terms which contains k separately. So that is the idea. So d naught. So then only you can compare, okay, a constant term and a coefficient of k terms. So next d1k minus 7 d naught minus 7 d1k and then plus 7 d1 plus 10 d naught plus 10 d1k minus 20 d1, which is equal to 6 plus 8k. Okay, so now look, collect the terms which is independent of k. So d naught minus 7 d naught. Okay, well, first I'll take d naught only. Okay, now 11 d naught minus 7. Okay, so 3 d naught. 3 d naught. Okay, now how many d1? Okay, d1, 7 d1 here minus 20, so minus 13 d1. So this is actually the terms independent of k. There is a constant term. Now k terms. So d1, okay, d1k and then d1k. Okay, wow. d1k, d1k, d1k. So 11, okay, wow. 11 minus 7, okay, 4 plus 4 d1k. The right hand side is what? 6 plus 8k. Now, okay, compare the constant term. We'll get 3d naught minus 13 d1 equal to 6. Similarly, compare the coefficient of k. So 4 d1 equal to 8. So this implies d1 equal to 2. Okay, we need to find d0 and d1 value. So now substitute d1 is here. So 3 d0 is equal to 6 minus 26. So plus 26. d0 equal to, I think whether I am doing any mistake, I don't know.
4 d naught, sir.
And the 4 d0 are there.
ஆமா சார். 11 minus
Okay, okay, thank you, ma. So d naught, okay, yes, 11 d naught minus 7. Okay, correct. Thank you. So 4 d naught. என்ன எனக்கு கேன்சல் ஆகல, அதான் இங்கே பிரச்சனை ஆயிடுச்சு. 4 d naught. Okay, now here also what? 4 d naught. Okay, now this is also 4. So d naught equal to 32 by 4, 8. Okay, now already I took the particular solution. T of k, instead of T of k, I took what? D naught plus D1k. So the particular solution is D naught. D naught is what? 8 plus D1 is what? 2k. Now solution, general solution. The general solution is what you have here, T of k. So T of k, general solution T of k is a homogeneous solution. What is homogeneous solution? B1 2 power k plus B2 into 5 power k. This is homogeneous solution plus particular solution is what? 8 plus 2k. So that's all. So you can verify the answer. So I think yes, B1 into 2 power k plus B2 into 2 power k plus 8 plus 2k. Still we need to find B1, B2. So I will leave it to you that part. So how to find B1, B2? So using t of 0 is equal to 1 and t of 1 equal to 2. So t of 0 equal to 1. Okay, va? So just I will tell you how to do it. T of 0 equal to 1 and t of 1 equal to 2. So t of 0 is equal to 1. So k equal to 0. K equal to 0 na, here what? You will get b1 plus b2 plus 8. b1 plus b2 plus 8. This is the first equation. Or you can write this one is b1 plus b2 equal to what? Minus 7. Second one, t of 1 equal to what? 2. When k equal to 1. K equal to 1 na, k equal to 1 na, 2b1 plus 5b2 plus 5b2 plus 8 plus 2, 10. So this implies you will get 2b1 plus 5b2 equal to 2 minus 10 minus 8. So if you solve these two equations, you get, I'll directly write b1. So first equation is b1 plus b2 equal to minus 7. b1 plus b2 is equal to minus 7. Okay, and then another equation is 2b1 plus 5b2 equal to minus 8. Okay, so b1 equal to minus 9. b1 equal to minus 9 and b2 equal to, I think, 2. Okay, 2. You can verify it. Now substitute those values in the here in b1 b2. So now the general solution is t of k is equal to b1 is what? Minus 9 into 2 power k plus b2 is 2 into pi power k is a multiplication plus 8 plus 2k. So this is the solution. Okay, so we'll move to the next problem. Okay, so here look at this one. This problem is very simple. So the problem here s of k minus s of k minus 1 minus 6 times s of k minus 2 is equal to minus 30. So actually minus 30 is a constant. Okay, so now what is the homogeneous solution? A square minus a minus 6 is equal to 0. So the roots are, you can check it, minus 2 and 3. Roots are real and distinct. The homogeneous solution is b1, some constant into minus 2 power k plus some other constant into 3 power k. Now the particular solution, already I told I put a table. Suppose the right hand side is some constant c, then you can take s of k minus 1, s of k minus 2 is a constant, some other constant. Either you can take d or d naught, whatever it may be. Okay, so here it is a constant, okay, minus 30. So that's why I'll take what? S of k is what? D. S of k is d. S of k minus 1 is d. S of k minus 2 is also what? D. So substitute here d, okay, minus d minus 60 equal to minus 30. So d gets cancelled. Minus 6d is equal to minus 30 na, d equal to what? 5. So that is your particular solution, because you are taking what? Instead of s of k, you are taking what? D. So particular solution is 5. Now the general solution is sum of what? Homogeneous plus particular solution. So b1 into minus 2 power k plus b2 into 3 power k plus 5. Still I need to find what? b1, b2. Using these two initial conditions, s of 0 is equal to 20, s of 1 equal to minus 5. Try to find what is b1 and b2. So here the new thing is what? The right hand side is constant. So again, instead of this constant, you are replacing by what? Some other constant. So everywhere d d. Okay. So d minus 6d. Okay. And then using I told that using these two initial condition, you should try to find b1 and b2, substitute here. So that's b1 is 11, b2 is 4. Okay, substitute the value of b1 and b2. Okay, here, okay, b1 is what? 11 into minus 2 power k, plus b2 is what? b2 is 4 into 3 power k plus 5. Okay, so we'll discuss next problem. So here s of k minus 3 times s of k minus 1 minus 4 times s of k minus 2 is equal to 4 power k. So what is the homogeneous solution here? The homogeneous solution is, okay, I'll take a snapshot and then, okay, just I'll explain. So what is a homogeneous solution? Characteristic root first is what? A square minus 3a minus 4 equal to 0. The roots are minus 1 and 4. Okay, the roots are real and distinct. So the homogeneous solution is what? b1 into minus 1 power k plus b2 into 4 power k. I think this part you can easily understand. But the right hand side is what? Something like a power k. Here 4 power k, a equal to 4. But here this 4 is coincide with this characteristic root. But this 4 is a simple root. So then what you will do here, instead of s of k, I will write here, instead of s of k, okay, it should replace by d for dk 4 power k. Suppose here I don't have 4 means, here suppose minus 1 comma 3, here you have 4 power k, then you can write what? D into 4 power k. There is no need to write this k. Next, s of k minus 1, d into k square, k minus 1 into 4 power k. Next, s of k minus 2, d into k minus 2 into 4 power k. So now this is a problem. So s of k, s of k now you should write what? D k 4 power k. Next, minus 3 times s of k minus 1. Minus 3 times s of k minus 1 is what? There is no need of bracket. D into k minus 1 into 4 power k. Next, sorry, minus 4 times s of k minus 2. Minus 4 times s of k minus 2 is d into k minus 2 into 4 power. I think I done the mistake here. K minus 1, here what? K minus 2. So here again 4 power what? K minus 1. Here 4 power k minus 2. So which is equal to, what is the right hand side? 4 power k. Now throughout I am going to divide it by actually 4 power k minus 2. If I group this one, it can write what? 4 power k minus 1. So that's why. So I have everywhere 4 power k minus 1. So you'll get here 4. Remaining what? If I divide by 4 power k minus 1, here 4. 4 dk. This is gets cancelled. Minus 3 into d into k minus 1. So 4 into 4 power k minus 2, that is 4 power k minus 1 gets cancelled. Minus d into k minus 2. The right hand side is only you have what? 4. So simplify further. my aim is to find the value of d. So 4 dk minus 3 dk plus 3d minus dk plus 2d equal to 4. So here dk, okay, I think here so I think plus 4 dk minus 4 dk gets cancelled. So 6d, sorry, 5d, 3 plus 2, 5, 5d equal to 4. This implies the d equal to 4 by 5. So now your particular solution is okay. D is what, 4 by 5 into k into 4 power k. So this is your particular solution. Or 4 by 5 is what, 0.8, okay, k into 4 power k. So now the general solution is s of k is equal to, okay, I think s of k is equal to, so I think what is your homogeneous solution? b1 into minus 1 power what, k, plus b2 into 4 power k, plus particular solution 0.8 into k into 4 power k. So please check it here. Okay, b1 into minus 1 power k, b2 into 4 power k, 0.8 into k into 4 power k. So whether I gave the initial conditions is there, check it. They don't give any initial conditions here. So if they give the initial condition, then you should find the value of what, b1 and b2. If they don't give, means you can stop here. Okay, maybe this is the last problem today. Okay, so here s of k, okay, s of k minus 4 times s of k minus 1 plus 4 times s of k minus 2 is equal to 3k plus 2 power k. So s of 0 is equal to 1, s of 1 equal to 1. The homogeneous solution is k, a square minus 4a plus 4 equal to 0. So it's a quadratic equation, has two roots. Both of them are what, 2 and 2. The homogeneous solution is of the form C0 plus C1k into what, 2 power k. So now the particular solution is what? I'll split into two parts. One is PI1. PI1 is 3k, that is a linear, and the next 2 power k. This is of the form a power k. So for particular solution 1, it is 3k. Okay, 3k means it's a linear. I already told that. So PS1. PS1 is what? 3k. So here instead of s of k, so you can replace by some d0 plus d1k. So I am replacing linear in k by linear in k. S of k minus 1 d0 plus d1 into k minus 1. S of k minus 2 d0 plus d1 into k minus 2. So now what is the problem? S of k minus, okay, S of k means d0 plus d1k, and then minus 4 times S of k minus 1, minus 4 times d0 plus d1 into k minus 1, close the bracket, and then plus 4 times s of k minus 2, it is d naught plus d1 into k minus 2, which is equal to write ps1 only 3k. Now my aim is to find what is d naught and d1. So d naught plus d1k minus 4 d naught minus 4 d1k plus 4 d1 plus 4 d naught plus 4 d1k 4 d1k minus 8 d1, which is equal to 3k. So first to check it whether anything cancelling. Yes, this is cancel for okay, and then d naught minus 4 d naught plus 4 d naught. Okay, and then constant term d naught, is there is any d naught? No, d naught, and then minus here you can look at this one, minus 4 d1. This is a constant term, and this one d1k plus d1k, I think I took everything, which is equal to what, 3k. So now d1 equal to what, 3. From this you can easily find out. If you compare the coefficient of k, d1 equal to 3. We compare the coefficient of k, and if you compare the constant term d0 minus 4 d1, d0 minus 4 d1 equal to 0. So d1 equal to 3 means d0 equal to 12. So now the particular solution 1 is d0. d0 is what, 12 plus d1k. d1 is what, 3k. So first we will verify it. 12 plus 3k. Yes, look at here. 12 plus 3k. Still I have pi2, okay, particular solution 2, that is 2 power k, but this 2 is coincide with what? Your characteristic root, but here the characteristic root is double root. So okay, I'll write here ps2 particular solution 2 is what? Is 2 power k, is 2 power k. Charge is very low. I'll put charge. Okay, yes. Okay, now, but we know that already. I told that this two is what, coincide with your characteristic root. Okay, characteristic root. Characteristic root. It is a double root. So that's why we'll take t of k. What is the problem? S of k. Okay, S of k is what? S of k instead of S of k, you should use the constant. You can choose any constant. They are taking d, or you can choose d0 or d1, d into k square, because it is a double root, k square into what, 2 power k. Next, S of k minus 1. D, replace k by k minus 1. So k minus 1 whole square, 2 power k minus 1. Now S of k minus 2, d k minus 2 whole square into 2 power k minus 2. Now in the replace everything in the given problem. The given problem is what? S of k. So S of k is what? S of k is d d into k square into 2 power k. Next, minus 4 times S of k minus 1. It's 4 times d k minus 1 whole square, okay, into 2 power k minus 1. And then plus 4 times S of k minus 2. Plus 4 times S of k minus 2 d into k minus 2 whole square into 2 power k minus 2. So is equal to write only PS2. What is PS2? 2 power k. So now this is 2 square. Okay, right. This one is a 2 into 2. So I'll combine this 2 with this 2 power k minus 1. So 2 power k I will get it. This is actually what? 2 square. Okay, 2 square. 4 is 2 square. I will combine this 2 square with this 2 power k minus 2. You'll get what? 2 power k. So everywhere I have 2 power k. Here 2 power k. Here also combine this 2 with this one. 2 power k. This 2 square. So 2 power k, 2 power k. That's why I am throughout divide by 2 power k. So what you will get? Dk square. I took 2 here. Still I have 1, 2. So minus 2 into d into k minus 1 whole square. So this 2 squares goes here. So throughout divide by 2 power k. This cancel plus d into k minus 2 whole square is equal to 2 power k. So what is our aim? To find the value of d. Okay, to find the value of d. So now dk square minus 2 into d k square plus 1 minus 2k plus d into k square plus 4 minus 4k is equal to, I think the right hand side is 1. I done the mistake here. It should be 1, 1. Now you can see here dk square. Dk square and then minus 2 dk square and then minus 2d minus 2d plus 4dk and then dk square okay and then 4d and then minus 4dk equal to 1. So plus 4dk minus 4dk gets cancelled. Okay, 2 dk square minus 2 dk square gets cancelled. So minus 2d plus 4d is what? 2d, which is equal to 1. This implies that d equal to what? Half. Okay, so now PS2. PS2 is what is PS2? D k square 2 power k. What is d? 1 by 2 k square into 2 power k. Now our general solution GS. What is I think I am using here S of k. So S of k is equal to what is complementary sorry, not complementary, homogeneous solution. Complementary function is we are using differential equation. Okay, homogeneous solution is what? C naught plus C1 into k into 2 power k plus PS1. PS1 we got what? 12 plus 3k. Okay, 12 plus 3k. I think here we got it. 12 plus 3k. 12 plus 3k, and then PS2 is actually half k square into 2 power k. So now I can check half k square 2 power k and check பண்ணிக்கலாம். We'll check it. Yes, half, this is half, it's not visible, half k square 2 power k. So this is your s of k. Still, we need to find C0 and C1 value. So how to get the C0 and C1 value? Using what? S of 0 is equal to 1 and S of 1 equal to 1. So that part I leave it to you. So you can find C0 and C1 value. C0 is minus 11. Okay, C1 is 7 by 2. Okay, that part you can do it. So actually there is one more note. I'll end up with this note today. So we have evaluated a particular solution for 3k. So I took PS1 is 3k, PS2 is what, 2 power k. Separately I done it. But we can also take instead of doing 2 pi, single pi. How to do? Instead of 3k, you should write a linear. For 3k is a linear, so that's why d0 plus d1k plus 2 power k. So you can write what? D2 k square 2 power k. This is for what? S of k. You can replace this by S of k, and S of k minus 1 is what? Instead of replace k by k minus 1, and S of k minus 2 means replace k by k minus 2. But my suggestion is don't do like this. If I do like this, you will do the mistake, because this expression is a little bit bigger. Okay, so that's why it is better to split like this. PS1 and PS2, you can do it. Okay, I'll stop here. Okay, if you want, you can some of the exercise problems here. So 6 problems are here, but only 4 solutions. 3, 4, 5, 6 only solution is given. 1 and 2 solution is not here. So those interested students, you can verify it. So we'll meet tomorrow. If you have any doubts, you can ask to me. Otherwise, we will meet tomorrow. Okay. Thank you.